Hi, I'll be giving you a full walkthrough of my helpdesk management system database, which I created using MySQL Workbench. This project is all about managing and resolving IT-related issues efficiently within an organization. The database helps record every problem reported to the help desk, assign it to the specialist, track its progress, and log how it was resolved. So let's dive in and explore how everything is designed, starting with the table structures. We'll start with the department table. This table stores all the departments within the organization like finance, IT, human resources, marketing, and operations. Each department has a unique department ID as the primary key and a department name field which is set as unique to avoid duplicates. This table is used to categorize callers and problems by their department, making it easier to filter reports. For example, tracking how many IT related issues were logged this month. Next is the job title table. This one stores all the job titles used in the organization, such as accountant, IT assistant, HR executive, marketing officer, and operations coordinator. It also has a unique ID, job title ID, as the primary key and job title name as a unique field. Keeping job titles in a separate table ensures normalization. So, if someone's title changes, you only update it in one place. This table connects to the call table through a foreign key, helping the system identify not just who reported an issue, but what position they hold. Now, let's move on to the caller table. This one shows information about all users who report issues to the help desk. It includes the call ID as the primary key, name, and foreign keys for both job title ID and department ID, linking back to the tables we just saw. This setup keeps the structure clean and organized, allowing us to easily connect each caller to their department and job title. Next, we have the help desk operator table. This one keeps track of all the staff members who handle and log incoming calls. Each operator has a unique operator ID, a name, and a contact number. I have also added a check constraint here to make sure that every contact number entered has exactly 10 digits. This helps maintains data accuracy right at the database level. Moving into the specialist table, these are the technical experts who are responsible for resolving the actual issues. Each specialist has a unique specialist ID, their name, an expertise ID, and a current law column that keeps track of how many active cases they are currently handling. The expertise idea is linked to another table called expertise area, which lists categories like networking, software, hardware, security, and system. This design allows the system to match problems with specialists based on their expertise area. Next is the problem type table. This defines different categories of issues that can occur, like network problems, hardware issues, or security alerts. It also has a field called parent type ID, which creates a self-referencing relationship. That means one problem type can be a subcategory of another. For example, a printer issue could fall under the hardware issue category. Now let's take a look at the most important table, the problem table. This is the central part of the entire system. It connects the caller, the operator, and the problem type all together. The column includes problem type, call ID, operator ID, and problem type ID. An optional fields for equipment ID or software ID if the issue is related to a specific hardware or software item. We also have details like call time, description, and status. By default, when a problem is created, its status is set to open. All of the relationships here are managed through cascading actions to keep the data consistent when records are updated or deleted. Next, we have the resolution table. This is where each problem solution gets recorded. It includes the resolution ID, problem ID, and specialist ID. There are columns for start time, end time, and a solution description. There's also a computed field called time taken, which automatically calculates how long it took to resolve the problem using timestamp diff function. Apart from that, we have two supporting tables, equipment and software. This stores inventory details about hardware and software used in the organization. By linking these assets to specific problems, it becomes much easier to identify where recurring issues are happening. Overall, each table is normalized, all primary keys and foreign keys are clearly defined, and differential integrity is enforced through cascading actions. The structure makes the system reliable, efficient, and scalable. Now let's move on to primary key and foreign keys, the backbone of relational design. Each table in this database has a primary key. For example, caller ID in caller table, operator ID in helpdesk operator, specialist ID in specialist, problem ID in problem, and resolution ID in resolution. Then we have foreign keys which link these tables together and ensures that all data relationships stay valid. For example, in caller, job title ID and department ID connect to their respective tables. In specialist, expertise ID links to expertise area. In problem, call ID, operator ID, and problem type ID connect to their tables. And in resolution, problem ID and specialist ID link to their related entities. These key relationships make sure that data always stay consistent. For instance, you can't have a resolution without a valid problem. Now, let's talk about constraints. These are the rules that make sure our data stays valid. I have used several types. Primary key constraints to uniquely identify records, foreign key constraints to maintain relationships between tables, not null constraints on important fields like name, call time, and description. So essential data can be left empty. Unique constraints on fields like operator contact number and equipment serial number, preventing duplicates. Check constraints, for example, ensuring contact numbers are exactly 10 digits and the specialist workloads can't be negative. And default constraints, such as setting the problem status to open and software license status to vary. All of these combined help ensure the database is accurate, consistent, and easy to maintain. Now let's move on to indexes, which are all about performance optimization. Indexes make searching and joining tables much faster, especially as the database grows. Here are the few examples. IDX call a name on call a name. IDX operator contact number on operator contact number. IDX specialist expertise ID on expertise ID. Indexes on serial number and equipment type. And IDX problem type, parent type ID to speed up subcategory lookups. In the problem table, I have indexed all foreign key columns and the status field, which really improves performance during joins and filtered queries. And in resolution, indexes on problem ID and specialist ID make retrieving linked records much faster. These indexers work together to make the entire system smoother and more efficient when running imports or queries. Next up, let's look at the views I have created. These are like saved queries that simplify data retrieval and reporting. View specialist workload. This joins specialist and expertise area to show each specialist expertise and current workload. Next is the view open problems. Displays all open problems including caller and operator details. View resolve problems. This shows all resolved problems along with who solved them, solution description, and the total time taken. View problem summary. It gives quick summary of how many problems exist under each category, showing resolved and pending counts. These views make it easier for operators, specialists, and managers to get the data they need without running complex queries. Now let's talk about triggers. These automate actions inside the database. Here are the ones I created. Trigger update problem status, update specialist load trigger, log problem insert trigger, and the last update timestamp. Here in the update problem status trigger, it runs automatically after resolution is added and marks the problem as resolved. Similarly, in the update specialist log, it decreases the specialist workload when they complete a resolution. And in log problem insert, whenever a new problem is logged, this trigger adds a record in the activity log table for editing. And finally, about the update timestamp, It updates the last modified time whenever a problem record is changed. These triggers make sure that the system automatically keeps the everything synchronized, problem statuses, special workloads, and logs without needing manual updates. Finally, let's go through the stored procedures. These are reusable SQL routines that automate everyday options. Here's what I have included. SP a new problem inserts a new problem automatically, setting the call time and default status to open. This stored procedure assigns a specialist, increases their workload, and inserts a work in progress resolution record. This stored procedure retrieves all open or in progress problems for easy monitoring. For the closed problem stored procedure, it updates a problem status to resolve, adds a final resolution record, and it decreases the specialist workload. And the last stored procedure, generate performance report, summarizes how many problems each specialist has resolved and calculates their average solution time. These procedures simplify the entire workflow from logging problems to closing them and generating performance reports, all while keeping the database consistent and secure. So to show what I have done, I will run a new problem store procedure. You can see in the action output tab, ran successfully. And that's a complete walkthrough of my helpdesk management system database built in MySQL Workbench. This database is fully normalized, designed with constraints, triggers, indexes, views, and stored procedures, all working together to ensure data consistency, automation, and strong performance. It's a powerful real-world solution for managing IT support operations efficiently. If you found this walkthrough helpful, thank you for watching this detailed walkthrough of the helpdesk database design.